Hello, everyone. Excellent. Okay. So many of you here, isn't there? Wonderful. How's iteration 3? You look really dead, a lot of you. Are you okay up the back? On a scale of 1 to 10? 10? Are you both a 10? Yeah, okay, perfect, excellent. But no, in all seriousness, like I know I did the Tuesday lecture for iteration 3, but the question for me still stands, which is like, what, are there any issues? Like, what are people struggling with iteration 3 so far, just before we kick into things? Or am I assuming that if you're here, you're not struggling? Such a quiet bunch. What about you way up in the stairs up the top? All good? Not good? In the middle? Yeah, no, it's actually a really common thing. So I'm sure some people have experienced this a bit where like iteration 2 maybe just doesn't go quite to plan. And that means that for a lot of groups, you start iteration 3 kind of feeling behind a little bit, where you're like, oh, we still have to finish off a bunch of iteration 2 stuff. And that can be super duper stressful. So all I would really say to those groups is like, it is quite stressful. However, a lot of students are in that boat as well. And the way that the auto mark is set up for iteration 3 is really great and useful because it just extends iteration 2. So the iteration 2 auto marker is part of iteration 3. That's kind of why we do it that way, so that there's some kind of motivation there as well for you to have to kind of finish it off. Now, if you do have iteration 3 questions that come to your mind throughout today, I would love it if you could share them, mostly just because the tail end of this course is not a particularly exciting thing. So like, as far as I know, I don't really know if UChow's got any plans for Thursday lecture next week, but there's the lecture today, which is about managing Git history and software complexity. Probably 2 of the least relevant topics for the project in the course. And then next week on Tuesday, the online lecture, we have it's a bonus lecture about web frontend. Also not really relevant to the course in any meaningful way. So it's at the point, and I got to try and manage this today because we're just not talking about anything that's particularly useful to you in a practical sense. And that's okay. So if you kind of want to tune out, or you don't like it, or you're like, yeah, it's not really for me, that's okay. And if you find it interesting because you feel like you're on top of everything else, that's also pretty great. But we'll try and be pretty zippy about it. But I will save some time at the end again if people have questions about iteration 3, because I know that's kind of front and center of people's minds at the moment. Now, the 2 things we're talking about today, one of them I mentioned is our Git history stuff. Now, the Git history lecture, in fact, let me just give you some context. So these lectures at the end of the course here are really, the reason they're at the end of the course is because, I'm not sure where the slides are. I'll just go find some of my old ones. We used to have these kinds of lectures peppered throughout the course, but the problem we ran into was that students just didn't care, because they're like, why do I need this, right? So it's not so much that we have a bunch of stuff at the end of the course that we think is useless, like this particular lecture. It's more that we go, well, this is useful, it's important to understand, but you're not going to apply it. And since you're not going to apply it, it's okay if we teach it in week 9. Because I know we've got like 4, 8, 10 people here in person. And then online we have like 17, right? Which isn't very many people. 27 people, and the reality is most people are going to watch to be honest with you, the reality is most people are not going to watch the recording today. That's just been my experience in the past. And for those who do watch the recording, they're probably going to watch it in like a week anyway. So it's just kind of like if we try and teach too much stuff at this point in the term, it becomes really, really futile. So we just kind of avoid it. That being said, why I want you to get excited about these 2 things today is because being able to rewrite Git history as well as being able to talk about software complexity are 2 really important things. And I haven't lectured you for most of this term, so I guess in a lot of ways I don't really have I don't know how to put it. I haven't really had to give you many existential rants, but I can't stress to you enough, just as people, anyone who's listening to this, how important it is to just generally upskill yourselves. I noticed that there's a general trend at the university, at most universities, not just this university, where students go through being like, how do I get a good job, right? Like that's like a big question. How do I get a job at Google? How do I get a job at Facebook or Meta or whatever the hell they're called these days? And one of the conundrums with that is it makes sense, right? Like you want to work really hard and you want to upskill and you want to get to a certain point. However, being just a little bit older than you now, what I've consistently seen is that people hyperfixate on that, and we don't really spend any of our time at university asking the question, once I get that job, how am I going to excel in that job, right? And that's a little bit of like a wanky thing to say, but it's really true, because you think about it, it's like you're at uni, okay, why do you volunteer for, I'm going to be the co-president of TSOC or something, right? And you go become the co-president of TSOC, and then you put it on your resume and you say you've got some leadership skills or whatnot, and it's all about like, how do I pad this thing out so that I present the best so I can get the best opportunity. But I can tell you from firm experience that there's a lot of people who go and get jobs at companies, and then what happens is you pick like a 3-year point down the line and their outcomes are massively different because they've gone and actually kind of upskilled in certain ways that maybe aren't the easiest to represent on a resume. And I think that's actually a really important point. It has nothing to do with the lectures today, because I'm not trying to set this up to be like, you know, learning is really important, so let's go learn about Git history, because Git history is probably not going to impact you at all. But it's a small thing in a bigger context of the question I would encourage you to ask yourselves with this limited platform I have to talk to you today is, what should I be doing to improve that will never appear on a resume and never be able to come up in a job interview? Right, that's the question I'd want you to think about, because it does have an impact. It's just hard because you don't see it for a while. Or if it does come up, if it is on your resume, it'll never ever be in that amount of depth, right? So a good example, like a fairly significant role at UNSW could be like being on the SRC Council, university councils, or president of a large society with like dozens and dozens of people in it, right? It's a line item on a on a resume. If you're the head of the newsletter for CSE SOC, or you're the president of CSE SOC, both of those things just look like a thing on a resume where you did a thing at uni, right? And you got some experience around leadership and stuff. But the difference in intensity of those two roles means one person is kind of left with like a lot more actual skills at the end of the day. And anyway, that's kind of the thing. So not really anything to do with Git undo. It's a pretty random lecture. But when you see things like this and you might be like, I don't need this for the iteration, I don't need this to pass the course, I don't need this to like get a job. It's like, cool, that's a great way of thinking. It's a baseline good level of thinking, because a lot of us are pretty screwed, but ask yourself a little bit beyond that sometimes. Okay, so coding together, Git undo. Sometimes we make mistakes using Git and we need methods to be able to resolve them carefully. Who's made a mistake in the project this term? Okay. Did you undo it by making a commit that undoes itself? Or like you just left it? what kind of mistake did you make that you left? Yeah, my friend in the pale white shirt.
At the end of iteration 2,
Yeah. You started merging stuff that failed tests. But like, what did you do? Did you just leave the test fail, or did you like update the code so the test didn't fail? Yeah, okay. So I guess what I mean by like, did you undo it was like, you made a mistake and then you had to patch it in some way. You couldn't really just like go back in time as if you'd never committed it and then commit the right thing, right? Like with Git and so far in the course, everything you do is a step forward. And if you go a step in the wrong direction, you take yet another step forward in the right direction. Do you have something?
Yeah, I messed up a lot of merge conflicts.
Messed up a lot of merge conflicts?
Yeah, so it didn't work at all. So I had to go back to like the previous commit and then like start over from that part.
Yeah, sure. Yeah, okay, cool. How'd you mess up a merge conflict? Did you forget to cut out all those stupid lines and stars and stuff, or was it just like you deleted too much code or something?
Yeah, I deleted too much code and also added too much code, like duplicated a couple of functions.
Merge conflicts are funny because when you have the early examples of them in like iteration 0 and 1, it's like, oh, it's just easy, we'll just get rid of that. And then if you get a really bad merge conflict, it's like, you're like, it's going to take a while.
Actually, I started a text from my teammates that I deleted all of his tests in one function.
Yeah, sure.
Yeah.
That makes sense. I'll try and share a funny story about that same kind of problem and how it messed up something big over the break. I'll have to look for a video. Yeah, so we make mistakes using Git sometimes. We need methods to resolve them. And the three things we're going to learn about are how do we do a hard reset at a point in time, or to a point in time, I should say. How do we amend the Git history, and how do we amend a commit? These are all very useful tools, not in the context of 1531, but in the context of your broader work. So I've mentioned this before. Everything we do with Git, we generally consist of going forward. We consider the Git history to be immutable, in the sense that once a commit is made and pushed to GitLab, it is forever in GitLab and there's nothing you can do about it. That's a good mentality to be in, and frankly, that's how most things work in reality too. With Git, sometimes we make mistakes and we want to be able to undo things either with resets or git commit amend, and we're going to have a look at these. So Atlassian, because they launched Bitbucket years ago as a competitor, now a struggling competitor to GitHub, they have a lot of good content about Git. It's a pretty typical business strategy, right? Like if you launch a competitor to GitHub, the best thing you can do is go and write a bunch of articles about how Git works, right? Because then you build up a community and you get lots of search engine optimized traffic. You'll see this happens a lot with, think of good examples. Anyone use Wise before? The like currency exchange thing? A couple of you do, right? It's like basically a credit card, but it's mostly designed for like us to use overseas, and it's really cheap compared to like say using Westpac or something. They do lots of articles about how ATMs work and what's going on with currencies, right? Like just trying to build up content. So Atlassian had a similar strategy. So they have produced it's a while ago now, these articles on like how Git reset works. And there's a lot of detail, lots of useful diagrams. I'm going to give you the shortcutted version today. But to do that, I'm pretty much going to go and make a repo. How do you do that? New project. I'm going to call this one, I can't kind of do this, and I can't do this with a normal course repo because we're going to destroy it. I'm going to call it history. And it's going to be internal. So you could go look at this later if you want. It'll just be like my Z number / history. And I'm going to go and clone it. Now, Kevin says, when will the slides be uploaded to the course website? I'll ask someone about that. It's a new course website. I don't actually know how to add the slides to it. So I'll have to ask someone about that because I just don't know. Normally someone else does that, but it's a good question. Frankly, the slides today and stuff are all pretty straightforward, so I don't think there'll be too much missing, and it's not needed for the iteration, but I will ask someone. So I've got my history thing here. It's an empty Git repo. There's nothing there. If I git log, there's nothing there. I'm going to go and check out a master branch just so you're kind of comfortable with it. Because the thing is, so has anyone had the master main problem with Git at any point in the course? So there was a general transition from the term master to main with a lot of, I don't know how to put it, like, I guess, Git systems, probably like a couple years ago. We still use master in the course just because I think it's kind of still where most of the collateral is online and stuff, right? Like when you Google Git, it's like mostly speaking about master. And because we create all your repos in the course, it's always master in the course. But if you just went to GitHub or do what I do here and make a new thing, the default branch will be a main branch. It's just what they call it. And I can go and, I don't know why there's nothing there, but I just went and like jumped on a master branch. There's no commits there. I'm going to go make a file called hello.txt. And I'm going to start adding some commits to it, right? This will take a moment. Git add hello, git commit 1, git push origin master, and that should come up to GitLab now. Wow, it's like we're back in week 1 again, isn't it? Remember this? Triggering, traumatizing, maybe. Do you see what with Git? Did it make sense eventually? Like it's one of those horrible things, isn't it? Like in week 1, you're like, what are they talking about? I have no idea what's going on. And then it just kind of eventually like, oh, this is actually not as bad as it looks. Yep.
So for the git push origin master, do you have to push origin master specifically?
That's a great. Yeah, do you have to put the git push origin master? So the short answer is if you don't include the origin master, most of the time it'll be fine. If you do include the origin master all the time, it'll be fine. Then you have to type more. Basically, when you git push, most of the time it's fine if Git knows what you're trying to push to. I think the most common instances that I've seen it like not work off the bat are like if I create a new branch called Hayden, and then I just like git push there. Maybe that'll work. Yeah, you get this error. Some of you would have seen this before. This whole like git push set upstream. This is like when you check out a new branch and you push, Git's kind of like, well, there's nothing to push to. It would be my oversimplified summary. So I don't know, when you say push, I'm like not 100% sure. You want me to like push this up to GitLab and make a whole new branch? You know, but once I do that push the first time, which I normally would just do by git push origin Hayden like that, it's up in Git now. And if I was to do more commits and then just do a git push, it's okay. I write it out explicitly all the time just out of habit because I consider myself to be quite an idiot sometimes. And it's like, it's nearly like, you know when like someone introduces you, like I'm like, what's your name? And you're like, Jimmy. And then I'm like, nice to meet you, Jimmy. You like reinforce it in your head. For me, it's a lot like that. Like I just like to type it out all the time to like keep reminding myself what I'm doing, particularly if I'm changing branches a lot. But yeah, it doesn't really matter that much at all. But yeah, we've got our little master branch here. We've got one commit. I'm going to go make a couple of other commits. I'm going to write 2 here. Fun fact, you can always join shell commands together if you're feeling lazy. Like I'll say another one, git commit here. I'll call this one 2. So that will do the add and the commit in the same line. Great. I'll edit it again, and I'll add 3. And I'll do another commit here called 3, and then I'll edit it again, and I'll do 4. Then I'll add another commit called 4. And then I'll push all those up to master. Should be up there. OK, so now I've got my 4 commits. So we've set up that repo. You can kind of see how it works. Now, we've got this first command here, which is git reset hard, right? Now, the hard reset is probably the most common Git history amending that I really see or deal with. Firstly, let me establish git reset hard will, if you don't include the hash part, it will reset all of the changes you have in your, I guess, working area to the very last commit that was made. So it's a very handy commit sometimes where let's say I go and edit this and I go and like write 5 and 6 or something. And then I'm like, OK, git status, git diff. And I'm like, OK, I've done a bunch of work. How do I just wipe that, right, since the last commit? If I just do git reset -- hard, it will wipe it back to the last commit that was made, right? So if you're ever like, no, I've screwed some stuff up, just go back to the last. Like, it's like has anyone played, I don't know if video games are still like that. But you know, you play a video game and then you just like, I screwed it up. So you just like reset it. And it goes back to the last save point. It's basically that. However, you can also do this if you'd like to go back to a previous commit. And all you need for that is you just need to grab, say, the hash, like this one here. Let's say I'm like, I didn't really need that 4 commit at all. And then I say git reset hard, and then I paste the commit hash, I hit enter, and then suddenly if I look at the git log, that commit's gone, right? You can think of this a few different ways. Some people will think of it like your unwinding history. I like to think about it as you're jumping to a point in time and forgetting everything after it, because that kind of works more generally for all these like different tree structures in Git. But it is really just like a way to say I want to go back to a previous commit and wipe out everything after that. Now here's the problem and why this lecture is kind of interesting, is if I say I want to push that to origin master now, I get an error. Now the reason I get an error is because on a lot of Git repos like the ones we set up in the course, as well as production repos, right, like at any kind of non-trivial company or organization, they'll have something like this in their Git configuration, which basically says that you are not allowed to force push to master. Now, what exactly is a force push? I would describe a force push as a push that causes history to be rewritten, right? Because think about how Git works again, and this might be useful now that we're in week 9. All a branch is a pointer to a commit at the end of the day, right? You can think of, like, Git's really simple. A commit has a parent. Every commit has a parent like a tree structure. And every branch is just a pointer to a commit. So when I have the branch master, it's just a pointer now to commit 3, and then 3 is a commit which has a parent, which has a parent, which has no parent. And that's the history. That's all it really is. But when I go to push that up to Git, Git's like, oh, I can't really work with this because Git has history, which is the commit 4, that my local thing doesn't have. Because what I'm essentially trying to do is say to Git, OK, no, master should point to the commit called 3. But GitLab's got it pointing to the commit called 4. And it's like, I can't just get rid of it. I can't just rewrite what's gone on. You can try and get around that with a force push. That's where you basically do a normal push, whether you have the origin master or don't, and you do dash force. This error comes up. You're not allowed to push code to a protected branch on this project. Now, you can do this with other branches, but usually that's OK, because who cares if you rewrite your own history on a dev branch, right? Because like it's not in master yet. Sometimes it gets squashed later anyway. We don't really care about that. But once everything's in master, once it's been integrated, it is important that we keep things pretty stable and we don't go messing stuff around. So I can get around it naturally by like turning this on or turning that off. And now it'll force push itself up. And here's the thing. Now that it's done that, the commit's gone. Is the commit actually gone? It's not really gone yet. What's technically happened is that I've just told Git that master points to a different commit. And because Git commits only look at parents, it kind of, figures it out. Where does that commit go? It's still technically there. I can show you what I mean by that. Like let's say I open up this commit, right? And what I'm going to do is I'm going to look at my commits again. I'm going to reset myself back to commit 2. Then I'm going to push that up. So it should be gone now. But let's see, commit 3, I had that before. This is still there, right? I'm like on GitLab, it still exists. Now this actually won't exist tomorrow because GitLab as a system has a method where it will go and prune commits slowly. It'll eventually be like, are there any kind of orphaned commits that just don't relate to anything anymore? They have no parent, like they have a parent, but they're not, they're not like part of any, you kind of get it, right? Like they've been cut out. This is actually interesting because sometimes what can happen, and we've done this in many courses over the years, is we will push out code to say, a repo, and we'll accidentally include all the solutions with, say, an assignment. Like we did this, I think, in a course like last year. We pushed out like a new quiz or something, and we pushed out all the solutions to the quiz. And we were like, oh my God, that's not very good. So what we did was we reset the Git history, and that was fine. And all we were really hoping was that no students were smart enough and knowledgeable enough to have already seen the commit, to have saved the web page, and then to have like linked it to people. Because the commit was there, and we couldn't actually speed up the cleaning up of GitLab. We just had to hope people weren't that clued in. And you know what it's like as a student. You're not that keyed in 2 hours after an assignment's released anyway. And if you are, you don't like save pages being like, if you see the solution, you're like, that's weird, that mustn't be the solution. They're not that dumb, so you just kind of disregard it. So that's like an example of that. It's really good for going back in time, reverting stuff. That's like the classic way to revert, well, not classic way. There's a command called git revert that you can kind of go look into. There's so much to Git, you wouldn't even believe it. Git revert's like more of a mature way of unwinding stuff. You'll also see other things like git cherry pick. Git cherry pick's another command where you can basically, like if someone pushes up a branch with lots of different commits, you can pull some in and out, and it gets pretty deep. But this is a great whammy tool that will just kind of get a lot of stuff sorted. Just to prove to you about the history's not technically gone yet, this is the 3 commit here. I can still, if I want to, technically reset to that commit and then push that back up because the commit still exists. Just hasn't been cleaned out yet, And now I've just kind of rewritten history back a bit. Again, I don't think that would work tomorrow because the jobs that clean this stuff out will have cleaned it out, but it's such a short period of time it doesn't matter. So that's a git reset hard. The other git reset is a soft reset. I usually just talk about this for completeness, but frankly, I think the best way to explain it, has anyone squashed a merge request before? What do they want you to do in this course now? Is it squash it or don't squash it? They don't want you to, they do? You're like, what the hell is squashing? Okay, so when you make a merge request, does anyone have an open merge request right now? Some of you do. I know you do. Okay, what's your group name?
Dream from T15C.
You have a merge as a dream. Yep. Merge request. I'm not going to look at approved 27 minutes ago. Merge conflict. Delightful. If I go to edit your merge request, there's actually a big button here that says this one here, squash commits when merge request is accepted. Who's seen that button before? Never dared to click it. So there's two buttons here. Now, I would call, these are very industrial buttons. I would say that typically people click these. The first one, what it does is once the merge request is merged, GitLab deletes your branch. This is pretty common because if you have 1,000 people working on stuff and they're making like a 2 branches a week of something, that's 2,000 branches a week. That's like 100,000 branches a year, of like code being just like random branches everywhere. That gets really hard to maintain, and then everyone's confused and it's cluttered. So that one you generally click. We don't get you to do that in this course because we do have instances where students are like, we have this in the past where they're like, oh, yeah, I did all the work, but it got deleted. You'll have to believe me. And we're like, oh, that's a rough one. Squash commits is when you go and make 5 commits. So let's imagine that you did this piece of work and it took 100 commits to do the work. But your master commit history is only like 20 commits because it's iteration 1. I don't know why you did 100 commits, but it would really suck if suddenly someone was trying to look through master's history and your dev feature, which included all the add this, undo this, add this, undo this, right? Think about the commit history on some of your dev branches. They might be a bit chaotic, right? It just squashes it all into a singular commit and just gets it done and dealt with. That one is also really useful in an industrial sense because it means that people trying to make sense of master don't have to look through your whole history. They can just look at one thing. We don't normally get you to tick that though because it makes it harder for us to again understand your work. So the university level, we don't really do that. Git reset soft kind of has a similar effect. We only really use this when we release your work. What I mean by that is the way git reset soft works is it's kind of the opposite to hard, where git reset soft, you go back to a previous commit, but it doesn't actually unwind the code changes, it just unwinds the history. And that's a bit of a funny concept, but I'll show you, right? If I git reset soft back to commit 1, okay, and I git log now, I've reset the history. That's just like the git reset hard, right? It just goes back to that point. However, all the code since then has not been deleted. It's been preserved, and you can actually see that. It actually stores it as uncommitted changes. So think about how I did this. I committed a 1, a 2, and a 3 in 3 separate commits, right? 3 separate lines. What this does is when I say I want you to soft reset back to 1, it takes me back to that commit, but that line 2 and 3 that I added, it's actually got that sitting there still ready to be committed. And if I make a commit, I could make a commit here called 2 and 3. And you'll see now if I push this one up, what it did was it basically took me back to 1, and then it had these 2 changes as staging, and I could push them again. So it's kind of it's also like a way of squashing, but then there's also a git squash command too. So, it's very confusing. That one's not that relevant though, so I don't want to spend a lot of time with it. This one I think is a little bit more useful, and I've started to use this one a lot more myself. It is a git commit where you can amend the commit. There's lots of things you can amend with a commit. You can amend the author name, you can amend the date of the commit, you can amend anything about the commit really, if you want to. However, we're going to focus on the naming part of it. So let's say I've got my git history here, and I think, you know what, my last commit 2 and 3, maybe I don't like the name of that. Maybe I think I screwed it up. So if I try and write, git commit 2 and 3 like this, I want to use the ampersand. If I try and commit that, what will happen when I hit enter is it's you've probably seen this before, right? It's there's nothing to commit. Okay. However, if I make an amend commit, what an amend commit does is it doesn't try and look for recent changes that you've staged. It actually applies this commit command to the last commit that's already committed to history. So when I run that now, and then I git log it, you'll see that what it did was it basically overrode the last commit. The author, me, and the date stayed the same. You see that happened at 11:41. It's now 11:42. So those 2 things weren't modified. However, the text was. Now, where you've got to be careful with this, though, and this is the really important part to note, notice that this commit hash is 78B55. Well, this one's EB50. right, is commit 1, and commit 2 is 78B5. When I go back up to what it was before, it's also EB50, however, this one's 39AD. So anytime you change a commit, even if you're just changing a full stop in the commit, or you're changing the date, or you're changing the author, it will create a new hash, a totally new commit identity on the history of the commit. And that's important, because if I go and try and push that up to master now, what's going to happen? It's not going to work, because this would involve rewriting history. Because even though it looks like the same 2 commits, and I've just renamed it, as far as Git's concerned, we've actually created a whole new commit and like knocked the other commit off the wagon. That's why it has a different hash, right? Different hash will mean a different commit there. So in that case, I would still have to force the commit. Once again, people wouldn't really do this on the master branch. You'd never really amend a commit on the master branch, but where it can be useful most commonly is not when you have to like update something on GitLab, but just with your own work, right? Like, has anyone ever made a bad commit message? You just like a typo or something, and you're just like, that was annoying. I guess that's forever now, you know, not going to change. A really quick one that you can go and fix up really easily. That's kind of it. Questions? Yeah. Yes. I don't remember how off the top of my head. But yeah, I mean, you can mostly do anything with Git if you want to spend the time Googling it, is like the short answer. But let's try it out. I have a vague memory. Let's say I do 4, and let's just say for that one file that I add it. And then I'm like, damn it, I didn't want to add it. I want it to be read again, right? I think you can git rm. I think. No, what is it? Is it git rm cached? Maybe I'm getting these mixed up. Yeah, okay. Oh, I've deleted it now. Okay. Well, okay, so this is what I mean. I'm not too sure. Git rm will remove it from tracking. So like the one I just did with git rm cache, that is like when you accidentally commit a file and you never wanted it to be tracked in the first place. A good example of that could be your database file, right? Let's say you accidentally commit your database file in a commit, and you're like, no, I don't want Git looking at that at all. You can git rm it all the way out. In terms of unstaging it, I'm not sure. I'll Google that in a sec. Yeah.
Just use
Git restore?
Yeah, you see it there over where it says deleted. Git restore stage.
Yeah, let me just get that back in first. Yeah, git restore, and you said staged?
You see it there in the terminal. See the changes to be committed. Now.
Hey! That is a remarkable exercise in comprehension. Thank you. Yeah, it's all right in front of you. No, I love that. That's it's honestly like, it's that real lesson. Like, you know, it's like trying to build the IKEA furniture without reading the instructions. Then you read the instructions, like, oh, it was right in front of me. Thank you. Yep.
So what did
Git restore in this case has basically said, please, like once something is green, once it's staged, it's now in like a holding area that when you commit it, that's what gets committed. So like if it's red, it's not in the staging area. If I try and commit here, right, it won't commit because it's like there's nothing staged. You've made changes, but you haven't kind of like packaged them up in the waiting room.
it's basically just reverse commit.
It's like reverse add. It's more like reverse add. Like when you git add and then git commit. So in a lot of ways, the earlier things we were talking about in the lecture were about undoing a commit or changing a commit. This is more like before you commit, you add a file, but then you think, I didn't want to add that file. I don't want it to be ready for a commit. I want to undo it. Now, this is a bad example because you might be like, why would I unadd a file? But the example that we were asked about was like, let's imagine you modified 4 files, but you only want to commit 2 of them, but you accidentally added them all. And now you're like, I don't want to wrap them all up in one commit. I want to maybe wrap them up in 2 separate commits. So can I remove 2 of them, make that commit, add 2 of the other 2, make that commit, kind of thing. That does happen to me intermittently. I won't lie. Normally, I'm just like, guess I'm committing everything then. If I just read that, that'd solve the problem. Yeah.
How important is it to make changes on the correct branch? Because sometimes if you work on the branch, you spot like an error.
Oh, it's a great.
But you don't changes you want. Yeah.
Yeah, that's a great question. I mean, in theory, it's very important. It's like in theory, okay, so like, you know, you're working on a branch and then you notice a typo, literally just like a capitalization problem or a full stop missing, some punctuation thing. What do? Do you just quickly fix that on your branch, or do you go make another branch, right? I don't like dogmatic answers. There's no right or wrong answer to it. I would say that the more serious you're getting with the work, the more important it is to do it on a separate branch. There's a couple reasons for this. One is that if you separate your work out, the little fixes will get usually approved quicker. So if I just give you an example, I had a lot of friends that joined Canva in 2020, and that was at a time they were like doubling in size, like a massive growth period. And a lot of my friends were taking, I think it took them, an average of about 6 weeks to get their merge requests approved. Because the people were too busy who were meant to approve it. Because of these larger companies, it's not always just like kumbaya, you know, grab your friend and be like, approve it. It's normally like the person, you're normally editing someone's code, and the person who originally maybe wrote that thing goes and approves it. So if you have a little fix you want to slot in, that's going to get locked up in that longer cycle, that more thorough review process, if you've got like a high risk and a low risk thing. The other thing is just like clarity. It helps to, it makes the merge request diff smaller. It makes it easier to understand what you're reviewing. If I think about my employees, and we're a company of 20, my private job, I would say that for me it would depend on what they're doing. If they notice like a little typo fix and they just fixed it, I'd be like, sure, you know, like it's not controversial. I think the bigger issue would be if they fix something that's non-trivial in the same commit, something that itself might be worth testing or thinking about or could break. Because that's the worst thing would be if you go and make a commit that basically does two totally unrelated things where it could separately break, because then there's one commit, if this one little quick bug fix you made, like say you were like, oh, there's a little bug in the user registration for loop. It's like, because if you screw that up, then you got to unwind the whole commit, and then you're like not sure where the problem is. Because a lot of the time what'll happen is that you'll deploy something and then you'll be like, well, this is where it went wrong, and you can usually isolate it to a commit, and it gets harder to pull that out. So it's kind of like an it depends, but I would say the short answer would be if you're doing a quick fix, is that quick fix in its own right a potentially risky change? And if the answer is yes, then you should probably split it up. And if the answer is no, you know, it's probably okay unless you're in a large company where they like really have the time and energy to be like, we have to be methodical about it. Cool. Any other questions? Yep. I have used Git Stash. I probably don't use it a ton. Normally I just dump it on a branch. So like if I'm working on something to that point and then I'm like, oh, there's something else I really need to tackle, usually I'll just create a branch, commit it to that branch, push the branch, and then check out master again and go look at the other thing. I know Git Stash works for that particular thing where I'm like, I just want to kind of stash my things and go do something and then bring them back. But frankly, I'd never had the discipline to figure out how it worked, and it never really felt I needed to. There'd be, if someone told me, if I got told, you can't keep pushing these BS branches up, Hayden, then I'd be like, okay, I should probably go use Git Stash now. But I know a lot of people that use it, yeah.
But it doesn't matter if you're pushing, if you're not putting in merge requests.
Yeah, and also you don't even need to push two, arguably. You can just make a branch and not push it up, so you're not even bothering anyone. That's the other possibility. But yeah, exactly. If it's not merge requests, then I guess in some ways it's even less of a concern as well. Cool. Yeah, well, I'll just tell you a quick story, and if I can find the video, I think I showed you guys the RoboCup video early on in the term, right? I think. Did I? I don't remember. Did I? I feel like I did, but terms are so short now, I get everything mixed up all the time. I feel like I don't remember which one this is the problem, because it's so long ago now. But there was I'm not going to find it, but I'll just talk to it briefly. But the issue that really stuck with me, and it wasn't even this particular game, because I don't think we recorded this one, but basically what happened was we talk about all this Git stuff, and the reason it's relevant is because like we're the blue, UNSW is the blue things here, and we had this one game where one of the robots basically just randomly throughout the game they started falling over. Like they just died. Like they literally just it's like passed out. Like their lights just turned off and they fell and hit the floor head first. And it turned out that a team member had made a bad push to Git, because the way these robots work is you basically have a Git repo, just like your project, and then just before a game you have a little shell command that goes and takes what's on master in that Git repo and it just pushes it out to the robots, right? So they have all the code in their little robot brains. And what happened was that essentially it kind of was like this, except this robot just fell over and then they all started falling over. And it turned out that someone had rushed to get some Git commits in just before the game, and they'd run into I think it was you with the merge request nightmare. They'd basically gotten a big merge request, and in their rush, they'd basically added a whole bunch of files, like 20 files, because they were like, I don't have time to go through and check every file. And they'd accidentally added all this useless junk with all these merge problems and whatnot, and it essentially just got pushed onto the robot. And it's interesting because, a lot of you have probably figured out the git add all, or the git add dot, or the git add star. I know there's lots of students that figure out quick ways to add stuff, and habits are a funny thing. There was this other thing in, this is a much less interesting story, but there was this thing back in SunSwift, the solar car, just again for context, SunSwift's a solar car team, where we used to have this trailer. In fact, I'm pretty sure it's our old one is parked behind this building or something. Anyway, you might see it, but I should just write car trailer being towed. So we had this trailer, and it kind of looked like this, but gigantic, because it had to fit a car inside of it. It was like a big box. Kind of like, that's pretty kind of close to it. And we used to have this rule, which I always thought was interesting. There's so many rules in the team, and I was the cause of some of these rules. But I've been told these rules by other people. So when I joined this team, there are a bunch of older people in the team who would tell me things like, one example was, you never, ever, 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 ever step over that middle bit there, no matter what. Don't cross the car from behind. If you want to get to the other side, you walk around the car. And me, everyone's like, it seems really annoying. I just want to step over the middle of it. And then the other rules we had were every time you drive the car, you go and you walk around the whole thing once. So let's say I want to hop in the driver's seat here. I go and I walk around the whole front of the car all the way down to the back and then back around the front, And I was like, that is also bloody annoying. What am I looking for? Elves or something? I don't know. And what was really interesting, the two things that really stuck out for me with that were there was this time, it was pouring rain. It was 5 in the morning on campus a long time ago. And we were running really late and we had to be somewhere. And we just loaded up the trailer. And someone in the team tried to jump over this, and in the wet they tripped and they hit their leg. They basically couldn't walk for a week, And I was like, oh, that's really interesting, because literally 5 minutes before that, it's rain. When it's raining and you are just getting soaked, you're like, this is going to be a bad 3 hours after you step out of the car and it's just you're just literally hopping in a bath. And I wanted to get to the other side, and without even thinking, I instinctively ran around the whole bloody car in the pouring rain, It's like just getting soaked by the second. And this other person didn't. They tripped over. And it was an interesting moment, because I was I didn't even think about jumping over it, because it was just it had just been ingrained into me. And habits are really interesting like that, right? And the same with the walking around the car thing. I don't have a video of it for you here, but back in 2018, we drove from Perth to Sydney in this big world record attempt. And I was doing my first driving stint. We were about 100 kilometers out of Perth. I was doing the second drive of the day, and I'm sitting in the solar car. And the trailer, you know, when the solar car's not in it, you still have to bring it with you. The trailer kind of was meant to get out in front of everyone. And I'm sitting in the solar car, and the trailer flies down the road. And what had happened was they actually, car, trailer, door down. They'd basically forgotten to even raise this off the ground. So like you normally like lower the whole back and the car drives out. They were in such a rush that they jumped in the car and drove off. And I saw this car flying down, this car and trailer flying down the road at like 80 k's an hour, and this back door is like bouncing along the road, just like up and down, like smashing, because they just didn't shut it. And I thought that was really interesting because you know what had happened? They were in a rush, and when they're in a rush, they just hopped in their car and left. And if they just walked around the car just once, they would have seen the bloody door flat open on the ground, right? You're not really thinking about that. I'm sure some of you have had that thing. You ever started driving and the boot's open? Is it just my mum is a bit silly sometimes, or does that happen to someone, you know, like something's not, okay, yes, I won't tell her that. But it's like, the reason I point all this out is because the funny thing about habits and the way, this is just a general principle again, habits exist to feel like absolute stupidity 99% of the time, but they exist so that when you're under pressure, you don't hesitate to behave how you need to behave, basically. And I saw this with Git. I feel like every year I'm alive on this planet more, I see more and more examples of it. So when you see things like, oh, you know, I should commit a certain way, or there's some other rule in software I should not do this, it's literally all there to feel stupid until it's not. And then it's really, really important. So and then we lost a game of RoboCup because someone did a bad Git ad because they were in a rush and they were like, these rules seem penal. What's the point of them? I'm just going to do it the quick way. So lots of interesting things to think about. There's no questions in the chat. So let's wrap this one up. Take a 5-minute break, and then we'll get stuck into the second part of today.
Sorry, I missed. Was it
Oh.
one just didn't get at all instead
Yes.
on just one file?
There was like 20 files to add.
Yeah.
And instead of doing, like, so basically, instead of Git adding individual files, they just did a Git add all like that. Now, there's a middle ground to that, because obviously if there's 20 files, a normal person's not going to go and type them all out either. But I think the main thing is the intentionality of how you do it. Because like, let's say you have a whole bunch of files like, you know, source auth.js, source auth.test.js, source, you know, quiz.js, package.json, package lock.json. You don't have to commit all of them. You don't have to type them all out. Sometimes you can do shorthand things like git add source star, git add source auth star, git add source star dot test.js, git add package star. You know, like all of those will kind of capture a few of them. And I don't want to demonize these because even though they're shorthands for doing collections of them, what I like about them is that usually it forces you to stop and think about, you're actually choosing the files, you know, off the top of your head. You're not just saying, nah, just do everything. And also, and the good thing too is that if you do this kind of thing long enough, eventually you build that habit again of you instinctively want to check through all the files. And if you do end up Git adding all, you've at least got those principles baked into you where you know, you've looked at them first. Because the worst thing you can do is just like not look at them. We used to have a lot of problems with this, weirdly, in the course years ago, but no one seems to really do it anymore. Like students just, maybe you're all less lazy than students during COVID or something, I don't know. But students during COVID would like Git at all like absolute menaces all the time, and it would cause lots of issues. So it's a good question. Cool. All right, let's 5-minute break. Won't take long, so we can get moving pretty quick. Yeah. Yeah, let me just leave it up on the screen for you. Just type that in. I don't know how to put it on the course website, but that's it there up on the screen. we are back. The last theoretical lecture for the term. Oh, that's crazy. So lovely to share our last in-person. I don't think is there an in-person lecture next Thursday? Does UCHA have one? I don't know. I'm really curious now. Oh, there's an online one. Okay. Oh no, there is in person. Cool. Yeah, sweet. Okay. This isn't your last in-person lecture. This is my last in-person lecture, so I'm glad to share it with you all today, even though you'll have to hear from me next week. But no, in all seriousness, actually, good job for turning up so many weeks in a row. Has anyone attended every lecture this term in person? None of you have turned up every week? That's incredible. So that's amazing that we're at that point. Not a single. Does anyone wish there was less online? Is there anyone here who's a real when I talk about, I gotta stop the record button, but when I talk about when I went to uni pre-COVID, and I'm 2/3 of people would just turn up to lectures every day. Everyone was on campus every day. Do you guys hear that and think, wow, that sounds like a nirvana with all these people around? Or do you hear that and think, I have to come to uni 5 days a week? Which side do you lean on? Is it that sounds like an amazing life one? And who's that sounds like death? Yeah. It sounds good, but you have to buy food every day? I was like that. I lived on campus for a couple of years because I didn't grow up in Sydney, and it was one of those colleges where they gave you the food. And me and my friend, we moved out of college in our third year, and we lived in some house in Mascot before Mascot got big. And then we came to campus one day and we had class at this time, and we finished the class and we just got out of class and we just looked at each other and were like, we got to figure out lunch. And then we just never had to figure out lunch before. And then I started wasting a lot of money buying a lot of food on campus. But what's people's current cheap advice for what's the cheapest kind of meal on campus? I'm a cheapskate with stuff, so I'll be like give me the best sub $10 lunch you can find. Help me out.
There's basically nothing sub $10. You get a sushi roll for $4.80.
Jeez. The one that used to get me for a while was there's the Vietnamese place up above Matthews. They did a bunch of banh mi's and rice paper rolls. They used to be $6 before COVID, but I don't know what they are now. I haven't looked. But the one that really piqued my heart was there's the chicken place at the IGA used to do $6 chicken burgers, big beefy fried chicken burgers. But they increased the price to $9.50, which has given me a lot of stress because that's still really cheap, $9.50 for it's not a tiny burger, but it's not big. But also, when someone increases prices on you and you're just this used to be $6. It's just kind of hard. So, inflation, right? Horrible. All right. So, software complexity. I didn't actually make this lecture. A lot of the 1531 lectures, maybe 60% of them, I was pretty involved with writing them years ago. But this one, there was another guy who wrote it. And his name was Rob. And Rob's an academic. He has a PhD, right? And I was like, why do we have to talk about this, Rob? And Rob's a real he's like, I need people that understand things. I want to understand fundamentals. The theoretical part's really important. And I have warmed to Rob's thinking quite significantly, which is that, because a lot of this lecture used to just have a lot of jargon in it about software complexity, which didn't really make a lot of sense. But it makes a lot of sense to me now, and I hope I can kind of convey its value to you in some way. Conversations. I think conversations is a really interesting word in this, why we're talking about it. We need to be able to have conversations about how complex software is. This probably only dawned on me towards the end of uni or after uni that to be a good software engineer, you don't just have to write code and do all of that, but you need to be able to articulate yourself and talk about things. And we're going to talk about a couple of these things at the bottom, but the question I think is so interesting is like, what is software complexity? If I asked you right now, if I pulled up your project work in front of the entire class and I just said, do you think your code is complex? You know, think about what you would say to that. If you said to me yes, I'd be like, why? If you said no, I'd be like, prove it, you know? So I think that's really the deep philosophical part, is like, how do you know if your code is complex? And then that's to the broader question of like, what even is software complexity, you know, as an idea? We kind of understand complexity generally, you know, it's like you might look at a bus map or a train map or something and be like, that looks like a complex network, or you might be like, that looks really simple. But with software, it might be a little bit harder. The way that Rob, bless his sweet soul, cited this is in a very academic way. You can kind of tell when Rob wrote some of these lectures because they'll reference papers in a true PhD student way. And he cited a paper which talks about the idea of breaking up complexity into two categories, which is one is called essential and the other one is called accidental. And this is a great way to break it up, because you can view essential complexity as essentially complexity that's inherent to the problem itself. It's complexity you can't really remove without not solving the problem, you know? And then there's accidental complexity, which is complexity that's not inherent to the problem. So let's say, like, I had to drive here today. Well, I didn't have to drive. I chose to drive like an idiot. But I drove here today from the southwest of Sydney, kind of around the Bankstown area, right? And if you don't take toll roads, there's a lot of left and right turns, right? If anyone's ever, you know, notice in Sydney, there's like some directions you can go which are just nice, smooth roads. Then if you decide to go perpendicular, you're like zigzagging everywhere, right? That's the kind of the classic case of Sydney. If anyone's tried to drive from here to say like Newtown or something, or you know, a few other spots, it's just kind of chaotic, or like Alexandria and things like that. Sometimes it's like you literally can't not create kind of crazy routes on the way somewhere in Sydney because it's just how the roads are, you know. But you can also take wrong turns. You can also decide to add even more crazy turns to it, or go a weird kind of backstreet way and add more complexity to that whole trip in general. I could give you a million scenarios, many of which are probably better than the one I just gave you, around how exactly it could be inherent or essential, I guess, or accidental. And this is quite true for software as well, because you can usually picture accidental complexity as complexity in your code that you could manage or mitigate or reduce with better software design. So you think back to the Week 5 lecture about designing for maintainability, right? We learn about things like, you know, breaking the software up and modulating it, or not repeating ourselves and things like that. If you can take any software engineering principle to make your code more maintainable and apply it, and the complexity reduces, it's probably accidental complexity. That means that you accidentally introduced it. In this theoretical world where all software should in theory be should lack complexity as much as humanly possible, whereas essential, again, is just a little bit different. So if we take your project, for example, if someone said to you, oh, your software is really complex because you know, you've got to handle quizzes, and you've got to handle sessions, and you've got to handle questions of quizzes and users and playing the quizzes, you'd be like, yeah, that is complex, but it's an essential complexity of it, because if I wasn't to have that complexity, I literally wouldn't even have the game. It wouldn't work as I wanted to. Whereas maybe some of you have written some code to decipher tokens, or you've done some, like who's written code back in weeks 3, 4, 5, 6 that you've recently looked at and been like, that was unnecessarily complicated. I have a simpler way to do it. Not yet. Yeah, do you have one?
Yeah, so I used find just equals that. I could have just used sum.
Could have used sub?
Sum.
Oh, sum.
Yeah.
So what did you use find for?
I basically just let quiz equals to download quizzes or find something, and then checked if the quiz was undefined to see if the quiz was valid.
Oh, sure. Yeah, okay. Yeah, exactly. Sometimes we write code that's like, that's a good example of a small piece of code that just is really complicated. Another good example might be like any time that people were doing like manual for loops to look up stuff or add things together as opposed to using filter or maps. Has anyone found that using a filter or a map in their code has significantly reduced just how complex the code is to understand? Got a couple of people. Yeah, so it's like that's kind of it. So when you look at code and you're like, is this complex? It's that question again. If there's something where you could have put a filter or a map, then that's an example of accidental complexity. You know, there's some really interesting questions that come from this, which is like, you know, how much of software is accidental complexity? To what degree will we be able to manage it in the future? And can you distinguish accidental complexity from essential complexity? Maybe AI and LLMs can start doing this more and more. Probably. Has anyone, who's been using ChatGPT this term? For little things, it's all right. I know you're not meant to use it for massive code generation, but has anyone used it to debug anything this term? Yeah. Have you, my friend? You haven't? You got to get on the bandwagon. No. Like it's a tricky thing. Universities haven't quite figured out how to use it yet. But I would say what I'd encourage you all to do is to, in good faith, ask yourself at what point do I feel like here's the thing I always think about. You Google stuff all the time, right? Googling kind of shortcuts your learning. I'm sure you could go read the manuals. I'm sure you could try something out for hours. But at some point, you think that Google is a tool I'm going to utilize to enhance my learning. And there's also times where you could use Google to skip your learning too, right? Like you could go find a whole solution and just use that. I would apply the same mentality when it comes to a lot of the LLM stuff. Is there are times when you simply hit a brick wall, right? This happens in the workplace too, right? Someone might try and solve a problem. They don't know, so they ask someone for help. Okay, well, you don't always have someone to help you. So maybe you've spent 30 minutes trying to debug a particular line of code that's not working. And then you think, you know what, at this point, I'm actually out of ideas. I've tried 5 different things. I'm going to go dump this into ChatGPT and be like, do you think there could be any issues here? I haven't also figured out the best way to communicate it, because I read this great post the other day that was like, thought it was so interesting. They were basically saying, one of the biggest misconceptions of LLMs is that it is going to make the bad programmers become the good programmers, you know, because they can go make code and stuff. But their counter argument was that it's actually going to make bad programmers still bad programmers. It's going to make good programmers exceptional programmers, because they're going to actually understand how to use it. I think this is actually quite interesting too, because like I've started to use LLMs a lot with my work, and what I've realized is I know exactly what to ask it all the time. I'm not perfect, right? Just like in general. I know what to ask it. I know exactly what I'm looking for. I know when it gives me a result, and I know when it's wrong, because it is just a generative tool at the end of the day, right? It's not actually solving your problem. It's just synthesizing stuff and hoping it's right most of the time. And so, you know, I'd implore you to play around with it, but obviously never let it feel like you're skipping an understanding of something, because you'll still need that. But the reason I mention it is because I've never tried to use ChatGPT for some code, but I would. It's week 9 now. We're at the end of the term. I would go take a chunk of code you wrote, dump it into ChatGPT or Google Gemini or something at some point, and just ask it, do you see anywhere in my code that you think complexity has been added unnecessarily? And it'll tell you something. You know what's great about that? If you take old code you've written, where refactoring it is not going to give you some advantage. It's not like a tutor's going to be like, wow, you wrote amazing code, here's extra marks. All you're doing then is using an LLM to explain to you something that maybe you come away from this lecture being like, I don't even know where I'd have complexity in my code. And again, if you really understand your work, the great thing is an LLM will come back to you with some suggestions, and you as a smart person will be able to easily identify what's BS or not. Whereas a bad program who doesn't understand stuff, they will instinctively just be like, oh, that looks an improvement, and then they will just copy the code and paste it in, and then it won't really work. So interesting questions about distinguishing accidental and essential complexity as well. So how do we measure software complexity? This one's really interesting, because measuring is really important. I usually tell people a story. When I was interning at Microsoft, I love this guy. Can't remember his name, but my boss, he had a boss. So I had a manager and he had a manager. So my manager's manager, they sometimes call it a skip manager, right? Because like you skip over your manager to another manager. And I remember, I think this guy's salary was like $1.5 million a year. And I was like 20, and I was like, that's a lot of money, It's like, how useful can someone be for $1 million a year? And what really blew my mind about this guy was he was mostly blind, and he just used to sit in meetings. And just he would like listen, and then he would just kind of give advice and be like, that's what we're going to do. And he didn't write any code anymore. And it was a really early marker for me of being like, isn't that the goal in life? For you to be that valuable blind, you know? Or like, you know, in some way, because right now when you're young, I think you think of like, I've got my hands and like, I've just, you know, I'm an input-output machine. And I guess we're all on a journey of like developing wisdom because there's value in that. But he was interesting. I didn't get to talk to him much because he was very busy. He ran like the small subgroup we had of like 60 people. But he said to me this thing all the time, which was like, he's like, the one lesson I've learned is that you need to measure everything, because if you can't measure something, you have no idea if you're doing any good at it or not. Otherwise, you're just guessing. And I think that applies every time we talk about something like this in my head, which is that, sure, we can talk about software complexity all we want. We can talk about that you've got complexity in your software and you're going to go reduce it. But if you don't actually have a way to measure it, how do you know you actually improved it? You know? This is true for anything. If anyone's tried to... Is anyone here a runner? Like, does anyone do half marathons or any of that? Yeah. You do? Crazy, man. I don't know how you do it. I try and run and I get like 400 meters in and I'm like, I couldn't be bothered. But I assume, how do you track it? Do you time it? Do you time your speed? Do you time the time? How does it work? How do you know you're getting better?
It's mostly feeling.
Mostly feeling.
Yeah, if you run the same
I regret asking you now.
But if you run the same distance over and over, I don't really care that much about time because some days there's a lot of people on track, sometimes there's not, stuff like that. But it's more about how tired was I when I
Yep.
was running, basically the same speed that I usually do.
Feeling. I love it. Yeah, that's good. How pooped do you feel at the end of it? Yeah. Well, that's a great counterexample that threw a wrench in the works there. But I think that's also really useful because what we're about to talk about is how we can measure software complexity. Because there are times when you can measure it. And if you can measure it, then you can try and reduce it and you can look at the numbers. But there's also times you can't measure software complexity too. Because not everything can be measured, you know? Like some things you can measure, like you can measure the linting of your code, you can measure, you know, the TypeScript errors, but it's very difficult to measure, say, how understandable your code is, right? Like there's no metric I could have for that. And any metric I come up with is just kind of BS-y, and the only way we can really manage that is to get smart people to be like, I think this is understandable, and for you and your group to come together. So whilst that asking of the marathon question didn't quite go where I want it to, it's also relevant because you just can't measure everything. So there's lots of things where even if you are, you know, say measuring time or efficiency or something like that, you do just have to rely on smart people having decent judgment. A couple of things that are hard to probably super quantitatively measure is coupling and cohesion. I believe we kind of talked about this vaguely in the Week 5 design lecture. Coupling's a measurement of how closely connected different software components are. So the idea here being that like if you have a quiz create and a quiz edit, sorry, wrong way around. Yeah, my bad, got this the wrong way around. So it's like if you have something like say quiz and auth, they're unrelated pieces of code. So you talk about coupling is the degree to which some things are like joined together. We usually refer to it as like tightly coupled or loosely coupled. So essentially you want unrelated pieces of code to be loosely coupled. Okay, that makes sense because the software is more complex. A way that I used to describe this to students a lot back, because I used to tutor 2511 for a lot of years, is you can usually tell how complex your code is by you can go through this yourself, is you go delete random functions or you go delete random files in your code base. And every time you delete a random function or delete a random file, how many errors will that create? Whether it's in your editor or compilation and stuff, because if your code is complex, like one of the biggest signs of complexity is, you know, they talk about, who's heard the term spaghetti code? Has anyone not heard the term spaghetti code? Wow, that's spaghetti code. No, I mean, spaghetti, there's no real visual representation for spaghetti code, but the reason they call it spaghetti is because when you pour a pile of spaghetti on the plate, right? If I said to you, I want you to pull one strand of spaghetti out, but I don't want to see a single other strand of spaghetti move, you know, like Jenga, but for spaghetti. You probably couldn't do it, right? Like you move one and they're all going to kind of get wobbly. It's the same principle here. It's like we want things that don't necessarily need to be related to be separated. And then separately, we want things to be combined together as much as possible that are related. Pretty benign stuff, you know? Paying uni fees to get some real high value insights here. Keep related things together and different things apart. But when we think about keeping related things together, what is like a loose measure you can use to figure out if that's on track? I usually like to think about how, you know, to some extent you can think about how few maybe imports you need. You can think about how few file changes files, you know, how would you say, like, to run a piece of code, how many files does that sprawl across? They can be really tricky things to measure because sometimes you want to separate your code, right? Like, we don't want to encourage you to say, well, everything to do with this should just be in one file, and then it's a massive file. You actually need to break these things up. So in some ways, cohesion can also be very difficult to quantify, and it does rely back to the feeling element, where you do just actually have to sit down and be like, okay, this really feels like it makes sense. One great way to measure these kinds of coupling cohesion things is just to get third parties looking at stuff. So, you know, you get we do this in the software space sometimes, is you'll sometimes isolate people from projects in its entirety for like weeks, and then you'll bring them in at the last minute so they have a fresh perspective. Because when they don't have because when you write bad code, if you're kind of exposed to it every day, you don't notice it going bad, right? It's a little bit like, it's like I had a friend I hadn't seen in a year, and I saw them, and we went swimming, and they were just like, they said something to me, like, they were like, you're a lot fatter than I last saw you. And I was like, oh, okay. But like, I didn't notice. It's probably like 5 kilos over like 12 months, because I'd just like been eating like a little bit every day kind of thing. And it's interesting because it's the same principle with software design. It's like if you add little bits of crap to your software all the time, and there's 3 of you, you're also going to echo chamber with each other because you all kind of get it, you know? You're all writing bad code together, and you're, yeah, improved, like we're all good. So if you can find a way to get, you know, whether it's like a tutor, I mean, you know, in courses obviously it's quite easy, but in reality sometimes it's just getting a third party in who doesn't see it. In a small org, that's pretty easy because not everyone's working on the same thing, right? Like this project's not a great example because you're all working on the same stuff. But that's probably, I'd say, the best way that I've probably seen to look at things like cohesion and coupling and really get a sense of like, does the layout of what we've done actually make sense? One of the ones that we can measure though, which is really interesting, is called cyclomatic complexity. Cyclomatic complexity is basically a measure of the branching complexity of functions. It is computed by counting the number of linearly independent paths for a function. That's quite a heavy concept. This one is cool though because we can actually apply an algorithm to it and to our code if we wanted to figure it out. It's something that I don't know why, actually. I think we talked about adding this to the course formally for a while. I'm not sure why we didn't. There's a formula here. The cyclomatic complexity of a function or a piece of code is e minus n plus 2, where e is the number of edges and n is the number of nodes when you represent your function as a graph, which represents the number of linearly independent paths, right? Okay, that's a mouthful and a concept to grasp, but let's think about it. This is a representation of this code in terms of the number of linearly independent paths. What are linearly independent paths? If you have a function and there's 100 lines of code, and then the end of a function, there's no one path through the function. But once you start adding if statements, else if statements, for loops, while loops, you're creating conditionality about how your code flows, right? Because you think about it, code just flows from start to end, no exceptions unless you add if, else if, for loops, while loops, do while, whatever the control structures are. So the cyclomatic complexity is essentially a measure of how many different scenarios can my function go through. And if you look at a function like this, well, we know we enter the foo function, a up here, and then we know that there's 2 different paths we can go through. We can either go through the if or the else. And once we go through the if or the else, where are we going to end up back at the end? We're always going to end up back at D, no matter what. Now you can actually draw these diagrams a whole bunch of different ways. There's no right or wrong way to draw these. But the cool thing is once you can represent your code in the format of a diagram like that, you can then apply the formula e minus n plus 2. So I look at something like this and I say, how many edges are there? 1, 2, 3, 4. 4 edges. How many nodes are there? 4. e minus n plus 2, 4 minus 4 plus 2, I get 2. So what does this 2 actually represent? This 2 in this case actually represents the number of linearly independent paths through a piece of code, right? Because there are 2 ways through that function. It's actually not as complicated as we make it sound. We have another example here. Except what I'm doing here is in this else statement, I'm putting another if statement there. So I know that we can start off our code here, and we can either go in the if statement or the else statement. But I know once I'm in the else statement, what can I do? I can either enter the if statement down here to D, or I cannot enter the if statement. And you know what? Whether I go in the first if statement, whether I go in the else statement and the next if statement, or whether I go in the else statement and skip it, all the code is eventually going to end up back at the end anyway. You know, so there's my visual representation of it. And when I plug that in, I've got 6 edges, 5 nodes, 6 minus 5 plus 2 is 3. And that makes sense because if you were to just look at this code without the diagram and I said, how many different possible paths are there through this code, you would say 3. You'd say either the if statement or the else statement, and then that else statement will either go through the if statement or it won't. Okay, so there's 3 different lines through there. We've got another one here, which is a loop, right? Loops maybe are where things get more interesting. Now, sometimes I've actually found that this can nearly make more sense if you don't think about it diagrammatically first in the early stages, because here, you can get caught up in all the A's and B's and C's, but think about this piece of code. How many different pathways are there through the code? Well, either I can never enter the while loop, or I can enter the while loop. That's really it. Like I either enter it never, or I enter it at some point and I stay in there till I quit. And both times I still have to finish the program anyway. So there's going to be 2 different flows through the program, clearly. Now if I draw it, I get a diagram like this where I say, well, essentially I start at A and either I jump to the end C, or I jump to B and then back to A, because we go through the loop and we just keep looping. You might be like, how do I know I'm drawing the diagram right? The cool thing about these diagrams, and we'll do an example together soon, is that you don't actually really, again, as long as they are vaguely right, they'll actually work fine. I'll show you what I mean by that soon. Here's a more complicated example though. This one's really interesting. I might kind of take this one and we can talk about it. Let's go to my favorite tool, JS Paint. All right, so I've got my little diagram here, and then you might be thinking, well, how do I draw this? Well, let's say, for argument's sake, we draw it really crudely. I'm going to make a little, well, I don't know if that's going to, how do I undo? I can't undo. Huh. Oh, Control Z. No, it's not working. This is going to be very painful. Right, so you think about the flow of the program, right? You're going to start here on this line. You're going to go down to this line here. Then you're going to go down to the while loop, right? Okay, so we can kind of say, well, I've got 3 nodes here so far. And then what's going to happen when I get to that while loop? Well, either A, I'm going to skip the whole thing and come down here, right? And then I'm going to get to the return line and then I'm done. Or I'm going to enter the while loop. It's probably a bit too big, but that's okay. I'm going to enter the while loop on this line here. Or I'm going to go to this other one, right? So I'm either going to go inside the if or the else in the while loop. Okay, sure. Now if I go in the else, I'm just going to end up having to go, I should really draw arrows on these to make them easier to understand, I guess. But if I go inside the else statement, all I'm going to end up doing is pretty much going straight back to the start anyway. Because I hit the else and then I just have to go back to the start. And if I hit the if here, I'm either going to do one of 2 things, which is I'm either going to go inside the if statement or I'm not going to go inside the if statement. And then both of those will end up going back to here anyway. Now that's a really ugly diagram. I wanted to draw it like this because this might be how you reason with stuff, right? I've drawn this more ways than I can tell you by this point in my life. Now let's first see though if we got it right. Well, let's count up the number of edges. I've got 1 edge there, 2 edge there, 3 edge there, 4 edge there, 5 edge there, 6 edge there, 7 edge there, 8 edge, 9 edge. Wait, did I count them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me just see if I've got this right. And then the number of nodes, 1, 2, 3, 4, 5, 6, 7, 8, 9. That sounds very wrong. But here's the interesting thing. If I go back to this for a second, they've drawn this diagram up here. I think there's definitely, there's going to be an edge. I need this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, there's 11 edges. I just didn't count it. Sorry. So my diagram here, I drew this horrible, ugly diagram. I drew with 11 edges and 9 nodes. And what does that mean? That means 11 minus 9 plus 2 is 4. Okay, and that makes sense because if you look at this diagram again, while loop, you can either go in or out of it. And if you go in it, you've got a few different scenarios there. This diagram, though, here is a lot more simple. Right? Try and put it somewhere there. That one's a lot more simple. What do you notice that's different about that diagram? Well, you notice that they didn't include things like this little return I did down here. You notice they didn't include things like going to the let year, because you know how I had that at the start. And the reason I think this is interesting is because you can draw these really simply and really complicated. However, the reason the more complicated diagrams still give you the same answer is because typically when you make them more complicated, all you're really doing is adding more nodes. And if you're just adding more nodes, you're generally only adding one edge associated with it. So for instance here, do I really need to add this like here where I'm like, yep, once it's all done, everyone comes down to line 15, and then from line 15 they get to the end of the function, right? Like I added that there, this little thing at the bottom. But this doesn't matter because if you just add a linear part of the flow, you add one edge and one node and they cancel each other out. That's why the formula works. If you're not too sure what I mean, if I just get rid of my big mess for a second, let's say you look at this if-else statement, right? And you're like, well, here's my if statement and here's my else statement. Okay, and here's like before it. So I know that like, you know, this is say like line 4 and 5 here. I know on line 4 and 5 I'm either going to go into the if statement or I'm going to go in the else statement. Now you could draw this one of two ways from here. You could either draw it the red way and say, well, when the if statement's done, it's going to go right back to the start, or when the else statement, and when the else statement's done, it's going to go right back to the start of the while loop, right? You could draw it that way if you want to. However, I could draw it a slightly different way, and I could say, well, you know what? When they're both done, I'm going to send them to like a common central point here, which is like the end of the function. Think about that as like line 13, 14 here, like the end of the if and else statements. And then that one here is going to go back up to the start anyway. And these two give you the exact same result, because if you think about it, what you did on this red case is you added 2 edges. But on the blue case, you added 3 edges and a node. So you added an extra edge, but you added an extra node. That's probably the useful thing about trying to represent this stuff, is that you don't have to kind of worry about the conciseness of what you're doing. You can essentially draw it out really elaborately and be like, yep, we go from line 1 to line 2 to line 3 to line 4 like that. And you can like literally break it up into absolute granularity, or you can make a really summarized thing like this. What I would generally encourage you to do, if you're just kind of starting out with this, just give me one sec. What's the plus 2?
What's the plus 2? Is that because there's 2?
Oh, that's just the formula. Just that. Yeah, it's a bit weird. Yeah, so what I mean is if you're not too sure how to do this stuff, the way I would generally encourage you to write it would just be to go, well, you know what? We start at line 1, and then we go to line 2, and then we go to line 3, and then we go to line 4, and then from line 4, I can either go to line 5, or I can go to line 10. You know, like you can actually write it out in this level of detail. And my point, maybe this is a better way of illustrating it for you, is that, because you know what I mean, like you could just write this out in a very prescriptive way and show where every line of code can go back to. If you write it out in this prescriptive way, it doesn't matter that all of this up here is redundant, because you've added a whole bunch of extra steps, but because every edge you add, which is another step, it just has one node attached, it just cancels each other out. That's the point of the formula, because it's E minus N. So this is the most condensed view of it, which is that you start at the start of the program, and then you enter the while loop, and then you either enter the if statement or the else statement, and both the if statement and the else statement end up back there, unless the if statement over here ends up in itself an if statement, which also goes back, and then at the end of the while loop, it goes to the end. Now, some people in the course will find these kinds of really concise diagrams really easy to figure out because they can, they have better abstract thinking. And then there's other people who won't have very good abstract thinking, which is not a bad thing. And for them, it might be easier just to write stuff out like this. To just be like, I'm just literally going to write out lines of code and be like, line 1 goes to line 2, and when you get to line 4, I can go to line 5 or I can go to line 10. And then what can I do from line 10? Well, from line 10, I go to line 11, right? Because like if I enter the else statement, I'm obviously going to line 11, and then I'm going to line 12 after that, and then after that, I'm going to line 13. And then where are we going to go after line 13? Well, at line 13, I guess I'd go to line 14, which is the end of the while loop there. And once I get to the end of line 14, I'm going straight back to line 4, right? Because once I get to the end of a loop, I go back to the start. So that goes all the way back to line 4. Do you know what I mean? Like you can just draw it out like that. And all the diagrams you see in the course are literally just versions of what I did, except people realize that you don't need all these intermediate steps because they cancel each other out and they just kind of take up space. Now, we're not showing you this. You know, there's lots you can go play around with. We're not showing you this because you're like, oh, that's your future. You're going to be sitting at your job one day with a pen and paper, looking at functions you wrote and drawing it out and then calculating stuff. People will think you're very weird. It's more a great tool to understand how it's calculated because there are tools out there, Node.js cyclomatic complexity, probably an NPM library, here's one. It's called, a lot of them. It's not very big. That's even smaller. SQO, oh. Okay. That's probably why we don't have it in the course. But, you know, let's say this little library here. It's basically something that you can run on your code, and it will try and calculate the cyclomatic complexity of stuff. Because if it's calculatable, it's quantifiable, and then we can apply it on our code. And where this ends up is that you could essentially, if you wanted to, work on a project where you could automatically calculate the cyclomatic complexity of functions in your code. And if you wanted to, in theory, you could add it to the pipelines where you could say, I don't want any function that has a cyclomatic complexity of more than 6. You know? And therefore, you actually have a measurable, enforceable way to reduce the amount of complexity in your code, which is essentially a mechanism to encourage people to break up their functions. That's what it would come down to at the end of the day. One of the drawbacks of a method like this is it only looks at one aspect of complexity. Like branching, if statements, else statements, for loops and stuff, does add complexity, but there's a lot of code that isn't about branching that can add a lot of complexity too. So it really only looks at kind of one source of complexity. And also you run into other problems where, what if people aren't fully educated like yourselves, you know, as in like what if people don't go through you know, some kind of learning like you do, and then they just get told your function's too big, break it up. Whereas in reality, maybe it's actually easier for a function to be that big than to be broken up. And we talked about this back in week 5, where sometimes you can take design rules so far that you end up actually making things worse for yourself. And that's not anything that you can really measure unless you come back to our marathon running feelings again. You know, you just kind of have to have a good intuition of that. That's pretty much it on this topic, though. I doubt there's any questions, but thought I'd check anyway. Is there any questions about software complexity? No? Hungry? Lunch? Okay. That's good. All right, well, sounds good. That's it. Thank you. Good luck for iteration 3. I'll see you around, all 12 of you, sometime around campus. Otherwise, I'll chat to you on Tuesday when we do our little bonus lecture if you want to watch it. Unless you're, you know, really full of time, I would probably just skip it. You know, like I'm sure you have better things to do in your life. Unless you actually are like, I really wanted to learn about it, in which case It's just front end. In which case you could watch it later. So to the like 5% of you that are super on top of your lives, go watch it live. But for everyone else, your lives are bigger than bonus lectures sometimes. So anyway, sounds good. I'll see you.